Hello everyone, welcome to the course on optimization methods for civil engineering. I am Rajib Bhattacharjya of Department of Civil Engineering, IIT Guwahati. So, this is a 12-week course and we will discuss mainly about optimization methods. So, both classical as well as non-classical methods and their application in civil engineering. Let me go through the content of this course. The primary objectives of this course are to introduce the students to the fundamentals of classical optimization techniques and also exposing them to the theory of different non-classical optimization algorithms developed for solving various types of engineering optimization problem. The course will also enable the students to apply the classical and non-classical optimization techniques in solving real world optimization problem. The solution of optimization problem using R, MATLAB and using MS Excel will also be discussed. I am not asking this question to the people who are knowledgeable in mathematics or in optimization methods. I am asking this question to the common people. So, are they using optimization in their day to day life? Now, the answer is the word optimization may be very familiar or may be quite new to you, but whether you know about optimization or not, you are using optimization on many occasions of your day to day life. I can give you some example. Let us see, I have shown here 4 photographs. The first one is a newspaper hawker. So, what he is doing? He is distributing the newspaper in a particular colony or in a particular area. The second photograph is an woman who is cooking or preparing some recipes. The third one is a forensic artist. So, what he is doing? He is trying to draw the face of the criminal based on the information he has received from the eyewitness. The fourth one is an ant colony. Now, if I look at all these photographs and these people even and you know they do not know about optimization, but even if you are looking about the newspaper hawker, about the woman who is preparing some recipes and the forensic artist. So, they may not be aware about optimization, but if you look at their activities, I can explain that one, that if you look at their activities, they are actually performing some optimization here without knowing any optimization method. So, I will explain this in my course how they are doing optimization, even an ant colony, how they are performing optimization in their various activities or when they are searching food. So, let me explain what is optimization, then I will go back to the figure again and then I will explain that. Now, what is optimization? Optimization is the act of obtaining the best result under a given circumstances. Okay. So, if you go back to these figures again, so you can see they are performing some activities and they are trying to find out the best result. Okay. So, what the first person is doing, the first photograph, he is trying to distribute the newspaper within a short duration. That means, he is trying to minimize his distribution time. The second one, what the lady is doing, the lady is trying to prepare a recipe and what best result she is expecting, that taste. So, that is basically she is trying to optimize the taste. Okay. The third one, the forensic artist. So, he is trying to find out a best result, that is the face of the criminal based on the information he has received from the eyewitness. So, he will after some trial, so he will draw the figure of that particular criminal and which is basically the similar to the actual criminal. And fourth one is the ant colony, and they are actually when they are searching food, and you can see that they are also traveling through the shortest distance. So, all of them are trying to get the best result under a given circumstances. Okay. So, all of them are performing some optimization. So, without doing optimization. So, if I need to define optimization, so optimization is the mathematical discipline which is concerned with the finding of maxima and minima. It is a maximum point or a minimum point of a function, possibly subject to constraints. Okay. So, there will be some constraint, or you can say these are the restriction applied to the problem, and based on that constraint. So, we are trying to find out the maxima or minima or maximum point or minimum point of a optimization problem or a function. So, I can define optimization. So, it is a either minimization problem or a maximization problem, maximization of f x or minimization of f x, and you may have constraint. So, that is subject to g x is less than. So, g x is a constraint less than equal to 0 and h x is equal to 0. So, if I say, so this is an optimization problem, mathematically I can define an optimization problem using these equations. Here I have shown you some function. So, this is a function and the objective is to find out the maximum point of this function. So, this is the optimization method will be used to find out the maximum point of this function. Similarly, for this function, so I have this is a maximum point and this is a minimum point, and I can apply optimization to find out the maximum and minimum of this function, and this is an optimization problem. So, here we have maximum points and this is a minimum point. So, I can apply optimization for finding the maxima and minima of the function. Similarly, I have shown you some other functions. Suppose this is one complicated function where we have more than one optimal solution, and this is also. So, we have several optimal solutions of this particular problem. Then similarly, this one also you can see that there are a lot of optimal solutions. So, maxima and minima also. Okay. So, these are all minima of this particular function. So, what we will do basically? So, we will try to apply the optimization method for finding maxima and minima of a particular function. Similarly, I can show you some other function. So, this is a two-dimensional function. So, we have x and y, there is an optimal solution. Here also this is one function. So, we have one optimal solution somewhere here at 0 0, and this is a little bit complicated function, and I can find out the optima of this particular function also. Similarly, this is a function with 4 optimal solution, and this is also you can see there are several alternate optimal solution and you have a global optimal solution, and here you have several optimal solution and one of them is the best solution. Therefore, solution of this type of function is not that easy. Okay. So, you need some specialized algorithm for finding the optimal solution of this function. So, I have shown here up to the 2 variables, but your problem may be of more than 2 variables. So, you may have 100 variable, you may have 1000 variable, you may have 1,000,000 variables in your problem. So, you can apply optimization method for finding the solution of those problems. Let us see some example problems. So, how I will find out the optimal solution of this particular problem. So, let me see the first function. I can have a simple algorithm that I have started my iteration from here, and I will go step by step, and finally, I will get the optimal solution of this particular function. So, this is similar to a hill climbing problem. That means, you are climb a hill and try to find out the maximum point of that particular hill in that direction. So, this may be a very simple algorithm to find out the optimal solution of this particular problem. Similarly, if I apply optimization method. So, in this particular problem, so you can see, so because it has several optimal solution and one of them is the best solution, and this problem I have solved using genetic algorithm here. So, you can see that your solutions are at the global optimal solution of this particular function. Similarly, this is a very complicated function because we have several optimal solutions. So, if I apply genetic algorithm here, and this problem also I have solved using genetic algorithm, and you can see that you will get the global optimal solution of this problem. Similarly, there is another function. Now, it has 4 alternate optimal solution, and again I have solved it using the PSO algorithm, and you can see that after suppose few iterations the solution will converge at a particular solution. So, these are some of the examples, and we can apply optimization methods for finding the maximum point or minimum point or maxima or minima of a function, and these are some of the examples. Let us see the content of this course. So, it is a 12-week course, and we have total 6 modules. The first module is Introduction to Optimization. So, where I will discuss about design variable, objective function, what is objective function, what are constraints, then problem formulation, and also you will discuss about calculus method. So, and we will also give one assignment from these particular contents. So, that is in week 1. Then week 2, so we will go to module 2, that is linear programming problem. So, it is a linear problem, that means all the functions, objective function, constraints are linear. So, we will discuss about linear problem in module 2, that is in the second week. So, we will discuss simplex method, two-phase method, big M method, duality, and also we will give one assignment from this content. The module 3 will start from third week. So, in module 3 we will discuss about classical optimization methods. So, in the third week we will discuss unconstrained single variable optimization problem, then optimality criteria, bracketing method, region elimination method, interval halving method, golden section method, and we will have an assignment. And in the fourth week, so we will discuss about gradient based method like Newton-Raphson method, the bisection method, then cubic search method. So, and we will also have an assignment. Then in the fifth week, we will have unconstrained multivariable optimization problem. So, we will discuss about multivariable optimization problem, optimality criteria, direct search method, simplex search method, and there is some other methods. So, that also will be discussed in this particular week, that is fifth week. And on sixth week we will discuss about constraint optimization technique. So, that means if you have a problem with constraint, then how we will handle that one. So, we will discuss about Kuhn-Tucker condition, the concept of Lagrangian multiplier and penalty function, and we will have an assignment from this content. In module 4, that is on the 7th week, we have introduction to meta-heuristic optimization methods, then what is random search method and what is guided search method. So, that will be on week 7 and we will have an assignment. Then week 8 we will discuss about genetic algorithm. So, we have two types of genetic algorithm. So, one is binary coded genetic algorithm, one is real coded. So, that also we will discuss, and we have an assignment from this content, and that is assignment number 8. On 9th week, so we will continue our discussion on meta-heuristic optimization methods. So, here we will discuss about particle swarm optimization, PSO, then invasive weed optimization, firefly algorithm, and we will have an assignment. Then next the module 5. So, in module 5 we will solve some optimization problems using software. So, basically solution of optimization problem using R and MATLAB. So, that will be on weeks 10, and we will have an assignment from this particular content. And then in the next week we will solve it using MATLAB and MS Excel. So, you can also apply MS Excel for solving an optimization problem. So, that will be discussed and demonstrated in this particular week. And the last week, that is your module 6. So, module 6, application of optimization techniques in civil engineering. So, here application of genetic algorithm, particle swarm optimization, invasive wave optimization, firefly algorithm in civil engineering along with the classical methods. So, that will try to solve some problem related to civil engineering in this particular week. So, as I said, so we will mainly use these 3 software. So, you can say that R programming platform, then we will use MATLAB and we will use Excel. So, you will learn basically how to solve an optimization problem using R, using MATLAB and using Excel solver. So, at the end of this course, you will be able to understand the importance of optimization. Then you will be able to apply the basic concept of mathematics to formulate an optimization problem. You will be able to analyze and appreciate a variety of performance measures for various optimization problem. You will be able to solve an optimization problem using R, MATLAB, MS Excel platform. So, this will also encourage you to use optimization techniques to solve real world civil engineering design and planning problem, and I hope it will promote research interest in optimization techniques. So, this is all about the course on optimization methods for civil engineering. So, with this I welcome you again to this course, and registration is still open. So, you can register in this course. Thank you very much.